Okay, someone made a really good suggestion on YouTube when they saw this induction heater build. This is the feedback induction heater with current control that we've been working on. And I now have a way to completely get rid of the current shunt, which has been a problem because I've had issues with melting of the wire and a lot of heating. So instead of using a current shunt, what they suggested I do is use a capacitor shunt. So that is done by simply getting some wire, some twisted wire like this, and connecting a small parallel capacitor, something like 10 nanofarads or 100 nanofarads. 10 nanofarads works fine because I just tested it. But here I have connected up 100 nanofarads, which translates to something of the order of 1/40th in the case of a 10 actually it's 1/400th if it's a 10 nanofarad capacitor, and it's 1/40th if it's a 100 nanofarad capacitor, which drops the amount of current flowing through that capacitor by 400 times. So with a 10 nanofarad it would be 0.25 amps flowing through that capacitor, and with 100 nanofarads it would be 2.5 amps flowing through that capacitor. And then if you take a so here's the capacitor. This is 100 nanofarads that I have here, but like I said, I've tested this 10 nanofarad and it works fine. And then you basically put a ferrite transformer. This one's got 40 turns on it. So it takes that, whatever amperage flows through the 100 nanofarad capacitor, which is 2.5 amps, and divides it by 40, making it 0.0625 amps. Now, using V equals IR, if you have, say, a 100 ohm resistor, you're going to get 62.5 volts showing up as your output. And if you have, I've got here 56 ohms, so whatever that comes to, so it'll be half that voltage, around 30 volts, which is fairly equivalent to the setup that I have now with the shunt. So let's see what this looks like. So I have everything plugged in, and I'm scoping the output of the shunt. So basically what this is the output of this shunt, this wire shunt with this ferrite transformer and 56 ohm burden resistor. And I'm comparing it with this much smaller setup here with the output across that burden resistor there. I tried higher resistances like 1,000 ohms, and it increases your voltage, but it also results in a phase shift. So it's important to use a low enough resistance. In this case, I'm using 56 ohms. So let me just show you these traces. So the blue trace here is the capacitor shunt, and the yellow trace is the wire shunt. So I've got an isolation transformer connected in. So let's see what this looks like. Here goes. I'm going to get it resonating. And as you can see, they're fairly much in phase, and it does away with the wire, with the shunt wire. So we're going to modify the setup once more, but no more shunt wire from now on. A little bit of noise is seen on that blue trace, and I think that's a combination of probe ringing and a setup on a board like that. It's not compact. And also the transformer isn't optimal. I'd probably use 100 turns instead of 40 turns. But you can see here it works.